days before the Industry Talent Night 2025, Rangamati gives us a plan, but it's mostly chaos discussed as well.
Okay, team. Performance order first. We need a plan that won't make the audience moves, okay? Magician first.
No, wait. Open with the singer.
Wait. What about the band? Okay, team. Relax. There are 5 performances already, and we have shuffled 10 times. Okay, forget logic. Let's draw number randomly, fair, fast, and no more arguing.
Well, I thought we do a surprise order.
For question number 1, the topic is performance order that related to permutation. For the formula of permutation is P of n equal to n symbol. The symbol actually means factorial. So, that means it multiply the number by every whole number below it. Because of we have 5 finalists, so n equal to 5. This is the step by step. 5 multiplied by 4. The answer is 20. 20 multiplied by 3. The answer is 60. 60 multiplied by 2. 120. So the answer is 120. Therefore, P of 5 equal to 5 factorial, which is 5 times 4 times 3 times 2 times 1. The answer is 120. For the interpretation, there are 120 possible ways to arrange the 5 finalists in the performance order.
Meanwhile, Yaya is facing the ultimate VIP drama, front row chaos.
Hey, Farah. Yes? We need to arrange the chair. So we have 4 VIPs, which is the dean, the lecturer, the celebrity judge, and wait, the sponsor. Well, do you have any opinion on that? I think I'm just gonna use the permutation method then. Let's calculate with me.
To find the number of possible arrangements, we use the permutation formula for arranging n distinct people, which is n factorial or n times n minus 1 times n minus 2 all the way until 1. Here, n equals 4 because we have 4 VIPs. So, we calculate 4 factorial. 4 times 3 gives us 12, then 12 times 2 gives 24, and finally 24 times 1 still gives 24. Therefore, the total number of ways to arrange the 4 VIP guests is 24.
Over at the prize table, Yasmin is trying to decide who gets what and slowly starting losing their mind.
Tote bag, hand fan, tumbler, notebook, earbud, perfume, and power bank. Only 3 can be chosen.
I vote for a random draw. Stressful.
Random? What if people fight over the tumbler?
Oh my god, Yasmin, stop overthinking. Okay, we choose 3 and then we move on, okay?
Fine.
Well, we will use the formula NCR where N is total gift, which is 8, and R is the number of selected prize, which is 3. So we'll use the formula 8C3, which is equal to 8 factorial over 3 factorial in bracket 8 minus 3 factorial. So since 5 factorial is both in numerator and denominator, we can cancel that out, which give the answer 336 over 6, and the last answer will be 56. So in conclusion, there are 56 different possible sets of prizes that Eva can choose from 8 available gifts. So this means that she has 56 unique combinations of 3 prizes, where the order of the selection does not matter and only the chosen items are important.
Alright, so next the 5-person subcommittee for the decorations, catering, and also stage setup. Obviously I'm automatically in, so 4 spot left from 11 people.
Farah must be included. That means 1 spot is already taken. So 11C4 equals to the formula 11 factorial over 4 factorial 11 minus 4 factorial, which is 11 times 10 times 9 times 8 over 4 times 3 times 2 times 1 equals to 330 different subcommittees. If 2 particular students cannot be in the same subcommittee, the total subcommittees with no restriction should be 12C5, which equals to 792. Whereas the subcommittees that include both A and B should be 5 minus 2 equals to 3, and 10C3 equals to 120. So we can just subtract these 2 answers, 792 minus 120, and we should get 672.
First winner, not Farah. Second, not Farah. Third, still not Farah. Why is not allergic to me? Relax, statistically, you might win at least 1 prize. Hope is still alive. 15% hope is better than 0.
Here is a tree diagram that represents all the 16 possible outcomes for Farah's 5 tickets. Each branch shows whether a ticket is a win or a lose. For question B, we want the probability that Farah wins exactly 1 prize. We use the hypergeometric formula because only 4 out of 120 tickets are winners. The calculation is bracket 5 chose 1 bracket times 115 chose 3 close bracket divide by 120 chose 4 close bracket. This gives about 0.1503, which resembles to 15.03%. For question C, we want the probability that Farah wins at least one prize. We use the complement rule. 1 minus the probability of winning nothing. Winning no prize is given by bracket 5 chose 0 times 115 chose 4 divide by open bracket 120 chose 4 close bracket, which is about 0.8416. So the probability of winning at least one prize is given by 1 minus the answer obtained, 0.8416, which equals to 0.1584, which resembles to 15.84%.
Guys, weather update. 40% chance of rain on rehearsal and 60% on the event. On the rehearsal day, the probability of rain PR is equals to 0.4 and the probability of no rain PR1 is equals to 0.6. On the event day, probability of rain PR2 is equals to 0.6 and the probability of no rain PR2 is equals to 0.4. We will use tree diagram as our reference to calculate the probability. So for rehearsal day, we have two probability which is R and NR. R refer to rain and NR is refer to no rain. Here, based on the tree diagram, we will come up with 4 different probability, which is in bracket RR, R and R, and RR, and the last one is NR and R. For question A, rains of both days. Probability of rain on both days is equals to in bracket RR. So 0.4 and 0.6, we will get 0.24, or in percentage is 24%. For question B, rains exactly one day. The probability of rain exactly one day is equals to, based on the tree diagram, is in bracket R NR and bracket of NR R. So it's equals to 0.4 times 0.4 plus 0.6 times 0.6. We will get 0.52, or in percentage is 52%. For question C, probability of rains on at least one day. Probability of rain at least one day is equals to 1 minus probability of no rain both days. So it equals to 1 minus 0.6 times 0.4. We will get 0.76, or in percentage is 76%.
After chaos, arguments, and last-minute panics, the MSU Talent Night 2025 team survived.